Battery recycling is key to creating a more sustainable electric vehicle industry. It holds the potential to reduce the carbon footprint of lithium-ion battery production and offset some of the requirements for mining and extraction. Unlike fossil fuels, metals used in batteries can, in theory, be recycled endlessly, providing material for new batteries. In long-established industries such as lead-acid batteries, recycled metals make up over 90% of current supply. Yet to recycle metals, there first needs to be supply, and in an industry forecast to grow more than 20% per year over the coming decades, it will take time for the pool of recyclable material to ever reach a large proportion of total demand. So how long will it take before recycling is able to provide a meaningful amount of battery minerals to the EV and battery industries?
So looking out to 2040, we're seeing that the demand for lithium, nickel and cobalt won't be completely plugged by the secondary supply, but we're seeing there'll be significant contributions. So for lithium, we're seeing that just under a quarter of lithium demand will be met by secondary supply. For cobalt, this is around just under 30%, and for nickel, this is around 11%.
When a lithium-ion battery reaches the end of its useful life, it is collected for recycling and sent to a pre-treatment facility. Here, the batteries are shredded. This produces a mixture of materials including scrap metal, plastic waste and black mass. The black mass contains valuable lithium, cobalt, nickel and manganese. The price of black mass in China, the world's most advanced battery recycling market, is typically based on payables to the prevailing virgin battery-grade mineral spot prices. As such, black mass prices closely correlate to battery-grade mineral prices. Black mass is then sent to processing facilities to extract the valuable battery minerals. Some recyclers use an energy-intensive pyrometallurgical process which heats the material up to extract metals. However, this process loses lithium to the slag waste, so increasingly recyclers are using hydrometallurgical processing, which is an acid leaching process. The carbon footprint of pyrometallurgy is much greater as it involves heating material to temperatures that can exceed 1000 degrees Celsius. It also produces an alloy of the metals, which needs to be further processed before it can be used in a battery. China leads in the use of both technologies, while capacity in Europe is mostly on the pre-treatment side of waste batteries, which creates black mass. This is then sent elsewhere to be processed. Currently, the vast majority of the feedstock of battery recycling is the process scrap generated by gigafactories in the production of battery cells.
In the near term, process scrap is going to be such a great deal of supply just because the gigafactory build out and the process scrap is coming into the scrap pool immediately. With end of life scrap, there's a delay as you're waiting for batteries in different applications to reach the end of life. Particularly within the EV industry, we're seeing that lifetimes are spanning anywhere between 10 and 15 years, and there's a lot of reports that these lifetimes are only going to get better when batteries improve.
Still, end-of-life batteries, especially those from EVs, are set to represent an increasingly significant portion of the global battery scrap pool feeding the recycling ecosystem. To ensure they can recycle their batteries, automakers are increasingly teaming up with recycling companies. In addition, materials such as graphite are also being recycled. Currently, the lithium-ion battery market is dominated by China, which means the country is the largest source of global scrap supply. But by 2035, this is set to fall to just over half of supply as other regions follow in generating lithium-ion batteries and scrap. Still, the industry is not without its challenges due to low raw material prices and a shortage of scrap. In addition, recycling of lithium iron phosphate batteries is becoming less economic due to the decline in lithium prices.
What we're seeing in the West is that there's delays in construction times, and with such a nascent industry, this is kind of inevitable. And so these unforeseen costs that are coming into play are really affecting the economics and the viability of these companies of getting online. Furthermore, the actual material that's available is quite low at the moment, meaning that securing that feedstock is going to be really important to enhance those economics.
Benchmark publishes monthly price assessments for black mass, offering greater transparency on the market price. Benchmark also produces a quarterly recycling forecast, which analyzes how much material will be recycled and returned to the supply chain out to 2040. Please contact us to learn more about the services we offer in the black mass and recycling markets.